3.3 relating.
Relating?
Relating?
Relating.
Whoa, this isn't family studies.
Oh no! Wait! It's relating SI and imperial units.
Right?
Math for Life!
Yeah.
Anywho, so we've talked about metric a little bit, or at least you've heard about it before.
I have.
But we've spent a lot of time talking about imperial units. And now, if only there were a way to convert between the two.
I think there is.
A very formal method, even.
You said you were going to teach it. You know this.
Really?
Yeah.
I've been forgetting these things lately. Oh well. Well, you know what I don't forget about? This now. Because I've just remembered this very formal method. And you know what? We've already been using it. So what we've been doing, say we wanted to convert 26.2 miles, right? We start with our value and then we multiply it by 1. But in that multiplication by 1, because that's the same thing as 1 here, we take the units we want to get rid of and put them in the bottom, and the units that we want to introduce, pop them on top. And we put that conversion rate in between. And now, with the different conversion rates between imperial and metric, you are actually provided those on your formula sheet. So I'll write them down here, just so that we have them for this current unit.
Okay.
But forevermore, you will always be allowed to use that formula sheet that provides these for you. So we have 1 inch is equal to 2.54 centimeters. 1 meter is equal to 3.28 feet. 1 yard is equal to 0.9144 meters. And 1 mile is equal to 1.609 kilometers.
Now, on your formula sheet, it says that these are precise SI imperial conversions, but they are technically, to some extent, still approximations. So they're very, very close, but they're not actually exact.
All right. So we're going to take a look and put all of this to use now. So we have a speed limit on a particular highway in the U.S., and it's 55 miles per hour. What is the speed limit to the nearest whole kilometer per hour? Well, I'm glad you asked. Math question that we didn't totally make ourselves. So we have 55 miles per hour. Okay? And hours usually HR. Now, I want to get rid of miles. I still want to keep my per hour. So what I'm going to do is I'm going to multiply by 1, getting rid of miles, so I have to put them on the bottom. And I'm introducing kilometers, so I'm going to be putting that on the top. I'm going to start off by introducing what I have there and saying that it is equal, that same thing multiplied by 1. And for my conversion, I know that 1.609 kilometers are in each and every mile. When I multiply those, I get 88.495. And notice that my units for miles have canceled out, but I'm left with kilometers on top and hours on the bottom. So I'm left with kilometers per hour, which is exactly what I wanted to. Now notice that it's asking us for the nearest whole kilometer, so I would be stating this as 88 kilometers per hour.
Neat. Our next example is based on a true story. You see, badminton posts can be purchased with diameters of 1 7/8 inches or 2 3/8 inches. And Mr. Athide, that's me, can only immediately find a ruler that measures in centimeters. I tried really hard to measure this thing properly, and the closest I got was that the diameter for the hole for the poles in the gym is around 4.7 centimeters. So that's pretty close to. And so which post should be purchased here? Do we get these 1 and some change ones, or these ones that are a bit more than 2? Who knows? There's probably no way to solve this. Just kidding. There is. Oops, I erased the R from ruler. I'll have to update that one day. Anyways, I'm going to do this by converting 4.7 centimeters, 2 inches. So I've got my 4.7 centimeters. I'm going to say that's the same thing as 4.7 centimeters being multiplied by something to get rid of the centimeters and introduce inches. And according to the formula sheet and also my brain, 1 inch is 2.54 centimeters. That means that 4.7 centimeters is about 1.85 inches. That was pretty close to. So then which posts do I actually get? We could probably reasonably say it must be these 1 7/8 ones, because we're obviously not more than 2 right now, given that our number starts with a 1. If we're curious, we can say that 1 7/8 is same as 1.875. I know we don't usually state pieces of inches in decimals, but that's what it's pretty close to. And we can see that these numbers are really close. Therefore, this really super guy named Mr. Athide should probably get the posts that have that 1 7/8 diameter. Wow. So when the pen sketches out, it just goes full on, hey? 7/8 diameter posts. The end.
But wait, there's more.
Oh.
In this next question here, it asks us how many square inches are in 1 square foot?
Is it 12?
No.
Oh.
But something I want to talk about before we even start this question is that square inches are the same as inches squared. And just like, 2 squared is equal to 2 times 2, inches squared is equal to inches times inches. So when we go ahead and try to convert these, because we're going to figure out how many inches are in 1 square foot, same, that foot squared is equal to foot times foot. We are going to use this idea, and since we have the conversion between inches and feet, we are going to do that twice because there's 2 inches that we have to convert to 2 feet, or vice versa. All right, so let me get rid of this stuff. And get back to the math. So we want to figure out how many square inches are in 1 square foot. So I am starting off with 1 square foot, and that's equal to 1 square foot. I'm going to write it out as 1 foot times foot. And I am going to multiply that by 1. Now, I want to get rid of my feet and introduce inches. So I want to get feet on the bottom and inches on the top. And I know that in every foot there are 12 inches. Notice that if I have feet on the bottom here and feet on the top, only one of those will be converted. But I need to convert both to get square inches. So I actually have to do this multiplication by 1 twice. Right? Because I'm looking at this, these feet will cancel out, these feet will cancel out, I'll be left with inches times inches, which happens to be inches squared. Alright, so I take 1 and multiply it by 12, and then again by 12, I end up with 144 square inches.
And there is another way of looking at this as well. So we've seen it with the units, which is very necessary. You can actually see where everything cancels out. But we each have our own preferences. For me, I like to actually picture this 1 foot by 1 foot box and know that this thing has an area that's equal to 1 square foot. But then this same box also has dimensions in inches, and we can say that if it's 1 foot by 1 foot, it's 12 inches by 12 inches. And so its area then must be 12 times 12, which is 144 square inches. So just another, as a pictorial rationale for it being 144. And that's how we do. Also, just again, another thing that's just my own personal preference. If I want to convert 1 square foot, as Ms. T said, we need to make sure we're implementing this conversion rate twice, one for each of these feet there. And what I do in that case is I say that I'm multiplying by my conversion rate, but I'm doing so twice. All this is a notational difference, because this thing squared is this thing right here. So they are exactly same. And they'll get you same result. Whatever your preference is, feel free to follow it. In this nextest one, we're going to convert 4 square meters to square feet, and we will round to the nearest tenth. And by that same logic, because these are square dimensions, we're going to multiply by the conversion rate twice. So we have 4 square meters. And I'm going to get rid of the square meters by having meters on the bottom, but making sure I get rid of it twofold. Conversion rate wise, according to the formula sheet, 1 meter is the same as 3.28 feet. What does that get us as a result? So if we have 4 being multiplied by 3.28 and then multiplied by 3.28, you can punch that into your calculator if you want. Beep, boop, bop, boop, beep. And you get an answer. Whoops, I should get rid of those. That's like 43.0336. But we're going to round to the nearest tenth. So this isn't our final answer. It's approximately 43.0 square feet.
Alrighty, looking at this last example, we are going to, oh look, Mr. A wants to redo his living room floor. Is that actually true?
To be honest, it's not really a priority for me. I'm focusing on my basement right now, and as I do so, I'm kind of focusing on that, and then there's a bathroom next to it.
Yeah.
And there's I don't know, there's a bunch of things
cool.
that I just kind of want to do before the living room, so it's not really high up there.
That makes sense. Oh, really? Cool. Oh, no way.
Yeah, I stopped talking.
Huh.
Well, you might as well do this example.
All right, so Mr. A wants to redo his living room floor.
Nope.
The room measures 355.6 centimeters by 533.4 centimeters. The box of laminate flooring each contain enough material to cover 50 square feet. How many boxes are needed to cover the whole living room? So I see right away that I'm going to need to know the area of my room, right? Because to figure out how much flooring I have, I need to figure out the area. So that's going to be one of my steps. When I figure out the area, because I have my units in centimeters, well, I'm going to end up with centimeters squared, because centimeters times centimeters, centimeters squared. But the material given to me is in a unit of square feet. So I'm going to have to do a conversion next. And last but not least, I'm going to have to figure out the number of boxes. So maybe I'll write those labels out right away. So I'm going to find the area of my room. I'm then going to convert to square feet. And then I'm going to figure out, maybe I'll do it here, the number of boxes. Oops, not boxers. Boxes required. All right. So to kick things off, my area, because again it's a rectangular room, is length times width, is the 355.6 centimeters times 533.4 centimeters. When I multiply that, I end up with 189,677.04 centimeters squared. Now I'm going to convert that to square feet. Do I happen to have the conversion from centimeters directly to feet?
Hard no. So we're going to have to do this in probably multiple steps in taking it to square inches and then going to square feet.
Oh, okay. So I need to start by saying, well, I have my 189,677.04 square centimeters. And that's equal to the exact same thing. I'm going to write centimeters times centimeters. My personal preference is to actually go ahead and do that conversion rate twice. That's what I prefer. Now I need to look at my formula sheet and figure out what that conversion is. So I know that 1 inch is 2.54 centimeters. And I have to do that twice to figure out what that is. You know what? I know that by doing this here, my centimeters will cancel, and my centimeters will cancel. I could very well go ahead and plug that in and get an answer of 29,400. However, what is also my personal preference is to do all of my conversions in one step. So notice here how I've gotten rid of the centimeters by ensuring that I have two versions of those, one at the top and one at the bottom. Well, I don't want to end up with inches squared, which I will end up with now. I want to end up with feet squared. So what I'm going to continue to do is I'm going to say, well, I'm going to get rid of my inches by making sure that's on the bottom and introducing feet. And I know that there's 12 inches in every foot. And again, I have to do that twice because I have inches. I have to get rid of both of them. And like I said before, you could very well do this in multiple steps. It's my personal preference to do this all at once. And when I plug that into my calculator, I end up with 204.166666667. So I'm going to say 0.17 square feet. Whew! So that's kind of nice. But I'm not done yet. And you know what? Maybe, because this was a little bit long, I'm going to put this down here. And I'm going to move everything up just a smidgen and deal with this last bit down here. So I know that I have a total of 204.17 square feet. And each box will cover 50 square feet. So that's 50 square feet per box. And when I go ahead and do that division, I end up with 4.08 boxes. Now, if I only order 4, I will have, well, not I, Mr. A will have a chunk of his living room floor that's uncovered. And I mean, I guess you could cover that with a couch or a piece of furniture, maybe a piano or something. There, yeah. But it's not going to be a nice surprise for the next homeowners. So you're going to say, I'm going to round up and get 5 boxes. Just like this was a word problem, we have to answer it with a word answer. So how many boxes are needed? We need...
Or is this me?
5 boxes to cover the whole living room. And by we, I mean Mr. A's constructional team, which is now all of us for helping him with his measurements.
Aw, thanks.
All right, so that's it. That's all. Test out these questions. See if they actually work. They should. They're in a textbook. They printed tons of copies of those.
Yep.
It'd be embarrassing if they didn't. But that's it. That's all. I hope you have a math-filled day and a math-filled evening.
Peace out, home skillets.
Adios, muchachos!